Hi everyone, my name is Rajashekar. Welcome to my channel. In this video, we'll be seeing complete process of lighting this massive Unreal Engine's Previs Map. For your convenience, I have created chapters for you to jump to specific topic, or you can watch it fully from the beginning. For people who are completely new to DMX lighting, I would recommend you to watch the older Chamsys video which I have shared in my channel. A card is coming up on the screen. You can watch that and get back here. I am demonstrating this video on an ultra-wide monitor to accommodate multiple windows in one screen for you to follow along easily. So watching this video in full quality is recommended for better visibility of tools. The video is longer, take frequent breaks and continue. So let's begin. So we'll begin by downloading the Previs Map from the Unreal Engine Marketplace and keep it handy. I would recommend do not follow along with the video because I have intentionally made mistakes for you to learn from them. Go through all the sections of video, observe the mistakes I make and make notes if possible, and then start fresh on your Previs Map. I recommend you to watch this with full concentration and understand the mistakes, why it was made and how to avoid it when you're working. Make a copy of Previs Map project folder before beginning to work on your own later. The Previs Map is highly resource intensive. If you have a normal PC, drop the settings to low for optimal performance. I will also be sharing outliner tips shortly, using which you can avoid UI slowdowns because of huge array of assets which we see in this map. We will briefly talk about how lights are placed across this map. There is one long truss at the top which contains sharpies. Firstly, here's 10 numbers of truss on the top which has sharpies, strobe and static heads which are otherwise called as truss toners. We have 6 numbers of slant truss and an arc shaped truss at the backstage top which has about similar light setup as before. We have matrix strips at the backstage wall along with sharpies spread across. On the center left and right we have 2 stadium poles with strobe and washes. We have 6 numbers of stage strip behind catwalk platform. The catwalk platform has sharpies, inner and outer layer of matrix strip. We have audience matrix strips spread across and static heads as audience lights spread across as well. Laser and fireworks are placed in the backstage. We will not be covering laser in this tutorial though. Pyros are placed randomly from backstage to center. In the outliner, we will create 2 folders, one for DMX lights and another for map stuffs. In that way, we can easily isolate both. When your scene is heavy, you can turn off map stuffs and vice versa when you don't want to see lights, especially when you're planning to add additional lights. Let's see how many lights we have in the scene. This is important for you to plan the patch correctly. Sharpies are called spot MH1 and MH2 in this scene and we have about 158 of them. Static heads are called as truss toners in this map. Couple of them are in the underground. Few are used in the backstage as scenic wash, few as audience lights, so there are about 248 of them. Majority of them are used in the top truss as truss toners. We have 14 wash lights, we have 222 matrix panels, strobe is 74, pyro we have 33, fireworks is 8, laser is 6. Totally we have about 763 lights in this set. When programming 763 lights, the first priority is to categorize them and divide them into groups for you to manage them effectively. We will see those methods now. We will divide the stage into groups by calling them as front, backstage, top, center, center left, right and audience. In each group, we will categorize the types of lights and quantity of them. In the top 10 truss, we have about 72 sharpies and 50 strobes altogether, along with truss toners as required. The one long truss which we see has about 8 sharpies. The arc-shaped truss which we see has about 8 sharpies and some static heads as truss toners and some as scenic wash for the flow. The 6 numbers of slant truss which we see has totally about 30 sharpies, 8 static heads, 90 matrix panels and 24 strobe lights on them. In the top 10 truss, arc and 6 slant trusses we have about 218 static heads as truss toners. The center left has 2 stadium poles with 4 wash lights and 12 numbers of strobe on each. The center right has the same setup. In the backstage, we have about 32 numbers of matrix panels on the wall, 12 numbers of Sharpies spread across 2 layers. We have 2 numbers of static heads placed underground, one on left and one on right. Fireworks across backstage. In the center behind catwalk, we have about 6 Sharpies. There are 50 numbers of matrix cells and 12 static heads placed for audience lights. Let's move on to catwalk, which has about 22 Sharpies along with 20 numbers of matrix strip left and right. We also notice stage strip, which has 6 columns and each column has 5 matrix panels, totaling to 30 matrix panels. Behind stage strip, we have wash lights. There are pyros spread across set from backstage to the front. That's pretty much the light positions and groups. Based on this, you can further categorize the outliner if required to front, center, etc., which I haven't done in this video. If you can do this, you'll be able to easily locate the lights based on the groups which I've created. We will begin by duplicating the existing DMX library to be on the safer side and work on it. 20 universe are enabled in default by using ArtNet protocol. Lights and modes are added and patches are in place perfectly. But we are going to modify the spot and wash modes for it to work perfectly with Chamsys. We are going to use clay packies, Sharpie and MIDB wash for this demo. The current modes of spot and wash in this library do not match, or perhaps not in order with actual lights which we are going to use back in Chamsys. Let's create spot and wash functions separately, but we'll be maintaining the same naming convention. We'll not change any names. Expand the window down fully to avoid screen jumping every time as you choose a function. The Sharpies mode are in place. Let's cross check to confirm the same. I am duplicating the spot MH1 and renaming it as spot MH2 as both are same. Let's do the wash modes now exactly as per lights mode order reference which I have. I am duplicating the wash MH1 and renaming it as wash MH2, same as before. Keep saving your progress then and there. This is important. You need to make sure to change static heads order in Unreal Engine so that it would match with Chamsys. In a similar way, make sure all the matrix panels don't have additional dimmer functions to them. They need to be deleted. I'll show you a video on how to do that. So this is what I was trying to tell you. In your DMX library, under fixture types, make sure all these matrix panels which you see, they will have an additional dimmer channel. You need to delete that. So next to the dimmer, you'll have this delete key. Make sure everything is deleted from each and every matrix panel. That is step 1. And step 2, so all these are static heads. You can ignore the sphere. So make sure all these static heads has the same order, which is red, green, blue, white and then dimmer. Now that we have changed functions of spots and wash, we need to modify the patch. As you can see on the screen, we will repatch spots and wash. Let's delete all the patches of spots from universe 1 to 5. The moment you add a patch, it goes to the last universe. So let's select the patch and change the universe 1 on the box provided on left. You can now either drag the patch to the first address or type in the number after unchecking auto assign address. Let's look into outliner specifically on how much spot MH1 and MH2 to patch. We need about 64 spot MH1. Let's complete spot MH1 patching. Copy the patch and keep pasting it as required. We need about 94 spot MH2. The patching of MH2 begins from third universe. Just like before, when you patch first MH2, it goes to the last universe. Let's follow the same steps as above and complete patching. I am changing universe number on the top, right and jumping back and forth. Left side bottom, I use universe number to change the patches to corresponding universe either collectively or as a single one. Let's follow the same method as above and complete the wash patching. We need about 8 wash MH1s and 16 wash MH2s. I made a mistake in patching all the washes to MH1, so fixing that. Since our patch begins from 0, when I say 0, if you take pyro, it would begin by pyro and the next one would be pyro 1. So 0 to 5 is 6 in this case. So please bear that in mind. So we need to plan the count accordingly always. No change in 7th universe for now, but we will get back to it later. Adjusting 8th universe patches. In the 9th universe, we see some blank spaces in between patches, which has been kept for a reason. But in our case, we will ensure patches don't have gaps in them throughout. Don't change order of patch by mistake. Make sure to fill the gap in order. Let's fix 10th and 11th universe as well. Twelfth to 19th universe has no change for now. Let's save and close. Now the next task is to relink all the lights to our new duplicator library and its corresponding patches using Open Patch tool. Make sure to select lights in order and ensure patch file order as well before linking. Let's adjust the details and outliner tab for us to easily check attributes and have two things in one place. Let's patch spot MH1 by selecting them in order and click on DMX followed by Open Patch tool. Select the correct DMX library and then first patch of spot MH1. Finally, click on address and rename. In this list of patches, the recently patched items is usually at the last since we removed repatch spots and washes. I usually do a random cross check to ensure everything went fine with linking. Let's complete patch for spot MH2 following same steps as above. We notice a mistake here. We see a different name of light instead of spot MH2's last light. What went wrong is we haven't patched spot MH2 completely in library. The last one was left off. That's a mistake. So I'm going to correct that. Getting back to our DMX library, adding the patch which was missed and saving the progress. I will have to select the specific light and link it individually. Now it's fixed. So this is one of the mistakes which could happen. Keep watching the video for more mistakes and how to fix them. Let's proceed linking wash MH1 and wash MH2 to its patches. Let's complete linking of strobe to its patches. The two underground static headlights are getting linked. Universe 9 to 11 are matrix RGB lights. Let's link them too in order. You'll find me linking lights as per universe. This is not necessary in Unreal Engine. You can link all in one shot provided patches are in order. but the workflow changes in Chamsys, which we will soon see in the following section. Let's complete Universe 12 light links, which is pyro fireworks. We have 14 firework patches, of which we only need 8. Universe 13 linking of lights are being done now. We again spot a mistake. Here, there are insufficient patches for scenic wash, which we need to fix it. We will get back to this. Let's complete linking of Universe 14. Universe 15 is in progress now. In Universe 16, we notice a couple of patches of stage strip is not in order. Like the first one is on second position, second is on first position. Sometimes this happens. So we will link them individually without using the tool. And once that is done, the remaining we can select in order and then collectively link light to its patches using Open Patch tool. Let's complete stadium light linking first. Proceeding to 18th universe now. Completing the final Universe 19. We are not using spherical light for this demo. With this, we have successfully linked all the lights to its patches for our new DMX library. We still have to fix scenic wash, not to worry, we'll take care of it in next section. Before we start this, let's quickly look into Chamsys program. As you can see, the demo mode of Chamsys only allows 18 universe and beyond is locked. Possibly we need hardware to unlock further. So with limitation in hand, we will have to carefully utilize universes and try to fit 763 lights within that. We can see there are a lot of free spaces within universe which aren't utilized properly. So this section will be about bringing down the universe usage within 18 in Unreal Engine so that we can use all the lights. I am going to shift all the strobe to a different universe which has space to accommodate. To avoid moving one by one, I retain the first strobe alone and delete the rest. I'll duplicate the remaining strobe patches there. You're seeing me dragging a patch file all the way to the bottom before moving it to another universe. I do this to avoid overlapping of this patch with another patch in that universe which is already there. Since we deleted patches of strobe, we will have to relink them to its light. We will collectively link lights and patches once we are done with fixing these free spaces. I am moving wash SL1 to a different universe as it's a total waste of a universe by keeping just 2 patches. Now universe 7 to 8 are free, so shifting patches from universe 9 to 7 and so on. Just like before, deleting all the stadium patches, remaining first one alone and moving it to a previous universe where I will duplicate it as required. We have managed to accommodate all the patches within 15 universes. That gives you more room to add more lights if required for 3 more universes. I am not adding any additional lights in this demo, but you can give a try on your own. Now I am cross-checking all the lights randomly and then linked to its patch for the final time. I am also relinking the lights to its patches which were deleted and repatched. The patches which were moved from one universe to another will not require any relinking. We have a problem here. We have missing patches for stage strip, so accommodating required patches of stage strip in universe 11. The missing stage strip patches are fixed now and relinked. I missed fixing scenic wash to its patch file again. It will be fixed in later part of video. Proceeding to check others. Trust owners patches are not in order, so we'll have to link them in 2 separate batches. Now DMX library is all set for Chamsys. But before we go to Chamsys, we have one more step in Unreal Engine. We have knowledge about number of lights in the scene. We also have divided sections of map as front, back, top, so on, and which truss contains how many lights information. But we also need information on every set of lights and its corresponding range of address and universe which they belong to. We will be programming lights in sections, right? So for us to prepare the lights layout in Chamsys, we need this information way ahead before we go there to make it more easier and to keep track of lights and which universe they belong to. This will also help us to troubleshoot lights in case of any issues. The process is time consuming, but you will get to know the value of it when we prepare the layout in Chamsys. I am going to use the same data we prepared before, but slightly modify it for us to input universe and address range for sets of lights. For example, if I take top 10 truss, I will define universe and range address of Sharpies, strobe, truss toner in that 10 truss. This will also contain outliner name of lights used in that particular truss. In this case, I know spot MH2 to 134 belongs to 10 truss. Now the next step is universe and address range. They are in universe 3 to 5. Now proceeding to do the same for strobe in those 10 truss. To get the spotlight visual reference out of the way, press G key. Press G again to bring it back when required. I got the range for strobe now. Next is universe and address information. Now the outliner name of a light is useful only within Unreal Engine and for our reference. But what could be more useful is the address range of it. So adding address range information to Sharpie and strobe as well. Sharpies of 10 truss are in the range of 3.1 to 5.113. 3.1 is third universe, first address, to fifth universe, 113rd address, 113th address. Now I am going to repeat the process for all the sections now. There will also be some mistakes which I will correct as and when I notice. When patching in Chamsys, you should always do it on per universe basis. Any gap in between universes can cause it to get patched wrongly. Let's fix the scenic wash which wasn't linked to its patch file correctly. We've been ignoring that for quite some time now. Before linking, I'm also making sure whether they are in order on the truss. There was a missing patch file of scenic wash, fixing that. There was a missing patch file for right stadium strobe, fixing that as well. That wraps all gathering of information we need for each set of lights. Let's proceed to the next section. The pre-built level sequencer will control the lights as soon as you press the play button in Unreal Engine. Let's delete the level sequencer. After deleting it, when you hit play button, there is no camera movement except few light issues which we will fix. The pre-built DMX library also needs to be deleted as it would cause conflict with current one we created. The light issue is because of Chamsys testing which I did for all Sharpies. We'll take care of that. Every time we test light from Chamsys, we need to see the entire DMX lights of the set. So the player position needs to be pulled back so that we can see all the lights. Let's open Chamsys and choose Simple Generic Console. Click Full. Now when we click Patch, we notice View Heads and Channels has pre-patched dimmers. The dimmers group is there in layout as well. We don't need them, so click on File, New, choose Yes, and then choose Normal Live. Now everything is empty. This is what we need to get started. Let's make sure all universe are enabled by default. Going to Setup, View DMX IO. In your case, the first universe alone might be disabled. Save the show file as required. Keep saving it frequently. Do not forget this. Let's begin patching. We will use DMX library as reference and patch on per universe basis. Universe 1 to 5 is for Sharpies and it's in order. Let's begin patching that. We have about 158 Sharpies. So let's go to patch, choose head, type clay packy, then type Sharpie, choose standard 16, stay in the view DMX tab before clicking patch it. Click patch it. Type 158 at the rate 1-1 in the box, which means we need 158 Sharpies starting from universe 1 and the first address is 1. Press enter and choose yes. The view heads tab will show you all different lights as groups you patched along with starting address of them. The view channels tab, which is chance tab, will give you detailed info of every light along with modes and address. Now we can see Sharpie is patched from universe 1.1 to 5.465. Let's cross check that with Unreal Engine DMX library. Let's test the Sharpies by clicking on layout 1 in the bottom. Select Sharpies group. Press locate on the middle right. They work fine. Now press clear in the middle below the dial. Let's proceed to patch wash now. We need 24 of them and they are in universe 6. We are going to choose MIDI wash from clay packy. Go to patch, choose head, clay packy, then choose MIDI B. Select modes as RGBW 17. Stay in view DMX, click patch it, type 24 at 6-1 and then press enter. If you stay in view channel or view heads tab while clicking patch it, Chamsys will patch it without even asking you how many numbers and universe you need it. It will patch it to the selected address on screen right away. That's why it's always recommended to stay in view DMX tab. The view heads tab has two groups, one for Sharpie and wash. Let's cross check it with UE. Washes are patched in universe 6 from 1 to 392. Let's test the wash. They are working fine. Let's proceed to patch 74 numbers of strobe as dimmers in universe 6. Stay in view DMX and follow steps like before. This time we choose dim/media and then generic dimmer. Click patch it, type 74 at the rate 6-409. Press enter. Strobes are patched and let's test them. Let's complete patching of wash SL1 in Chamsys. For this, I'm going to choose head, generic, RGBW dimmer, patch it, type 2 at the rate 6-483 and then press enter. Let's test the RGB dimmer lights. They work fine. Let's proceed to patch matrix RGB from universe 7 to 9. Let's patch universe by universe than doing it all together. To patch this in Chamsys, we are going to choose head as generic LED RGB 5x5 panel. Click patch it, type 6 at 7-1, press enter. Why 6? Because a single matrix panel has 15 cells. We have 30 matrix panels in one universe. So 30 multiplied by 15 is 450, that is, it occupies 450 address. A 5x5 matrix panel patch occupies 75 cells. So 6 multiplied by 75, we get 450. So it exactly occupies same address as our patch in Unreal Engine. Let's test it. It works fine. The 6 numbers of slant truss is where these matrix panels are located. Let's patch pyros in universe 10 as dimmers. They are patched and works fine. Let's patch fireworks as dimmers as well. I right away clicked on patch it because the generic dimmer head which was used before is active. Make sure to check it every time when you click patch it. Fireworks are patched and works fine. Static heads, pyros, fireworks are sharing dimmer channel. That's why everything is triggering at once. We will split them into groups in next session once patching is complete. There are 24 stage strip panels in this universe and balance 6 continues in next universe, and they are in order. So 30 panels in total, and they follow the same math as before. I am patching matrix panels differently here. Instead of patching 6 panels, I am only going to do 4. Then I will individually patch balance 2 panels one by one in the view channels tab. You can do that by selecting an address in view channels tab and click on patch it. It will patch the entire set as long as the head which is chosen is active. Stage strips are patched and they are working fine as well. The audience lights are static heads. Let's patch them as RGBW dimmer. Audience lights are patched and working. Let's proceed to patch audience strip lights. We have about 50 of them and each strip has 3 cells. So 50 multiplied by 3 is 150. A single 5 by 5 occupies 75 cells as I mentioned before. So 75 multiplied by 2 is 150, which will do the job. Let's try to patch 4 instead of 2 and let's see how we can fix that excess patches. The audience strip only requires patch up to 317 address, but we have patches excess up to 467. To delete the excess patch, either go to view head or view channels and select the panels. Press remove on bottom right. Repeat the same for next set. We have managed to remove additional 2 sets of matrix panels, and now it exactly matches with our Unreal Engine address, which is up to 317. Let's test the audience strip and they work fine too. All the LED panels are grouped. We will separate them out as well in the next section when we prep the layout. Let's proceed to patch Scenic Wash. Scenic Wash is patched and works fine. Scenic Wash really looks great when colors changed. Let's patch cat strip panels. We have 20 number of cat strip, so 20 multiplied by 15 is 300. So we need 4 sets of 5 by 5 matrix panel. That is 4 multiplied by 75 is 300. Cat strip are patched and tested. Let's patch stadium light strobes as dimmers. Stadium lights are patched and tested as well. Let's patch matrix strips at the backstage. We have 32 panel. 32 multiplied by 15 is 480. In this case, we will have to patch 7 sets of 5 by 5 matrix panel because 6 multiplied by 75 is 450 and the 7th set is 525. To avoid programming challenges, we go with this one. Since it's a virtual setup, it's okay, but in real stage and patches, we need to make sure we don't waste addresses in universe. I'll begin by patching 5 sets in Chamsys and will show you how to patch directly in View Channels tab. 5 set occupies 375, but we need up to 480. Let's patch one more set and it goes up to 450, which is still not enough. Let's patch one more set and it goes up to next universe's 13 address, which is fine for now. Let's test the matrix panel, and they are fine as well. Now trust owners are pending. They occupy from universe 14 to 15. We already have trust owners starting from 33rd address of the universe 14, so there is no clash anyway. We patch trust owners as static hits, universe by universe like before, as there is a small gap in universe 15 end. While testing trust owners, I figure out they are not linked properly to its patches in Unreal. Fixing those now. They are fixed now, completing the final set. All trust owners are tested. I am going to do a final test on all lights. There is a small problem on one of the trust owner in the top pillar. I'll be fixing that in upcoming session. We are extensively going to use the data we prepared on universe and address range for each set of lights to create layouts in Chamsys now. Let's begin. We will begin by creating a group for top 10 truss elements. Sharpies are from 3.1 to 5.113. So create a group for it, select Sharpie group, click on view heads, then select the Sharpies in that range from universe 3 to 5 by holding shift. Begin by left clicking on the first element before proceeding, which would uncheck everything which is selected, because the moment you click on Sharpie group, every Sharpie is selected. That's why we need to left click on first element to uncheck everything and choose fresh from here. At any point in Chamsys, if you notice the tabs disappearing, it's because of the Alt key. Press Alt to make them reappear and then disappear as needed. Maximizing the Chamsys window for us to see the numbers better. There is no easy method as such. We need to select them one by one carefully and in order. Those are the Sharpie lights of top 10 truss. Now click locate to see them. Click record, which is REC. Go to view groups tab. If you don't see tab at the top, press Alt, then click on an empty slot in view groups tab, then click clear. That creates our first group. You can select and locate it now. Let's give a name for the group to identify it. Click on set, click on the new created group, give a name and press enter. Let's proceed to create a group for strobes on this truss as well, following the same method as above. Repeating the steps again, click dimmer group, click on view heads, then select the strobe in that range from start to the end address by holding shift. Begin by clicking on the first element before proceeding. Here you're seeing me select dimmer channels from 6.409 to 6.459, which are for strobes, and follow the steps above to record, store and rename the group. Look closely on screen and see as I create groups for everything and prepare a layout. So the top 10 truss lights are grouped. I will follow the same method to break down the entire set of lights and create groups for them. At any time we can move the groups by clicking on move, select the groups to be moved and then click on an empty slot. Sometimes, due to a draw distance, you might not notice a light lit up, so move closer to them to see them enabled. If you selected a light by mistake while holding shift, click on them again to deselect. While grouping one of the truss toners from 10 truss, it is getting mixed up with the 6 LAN truss at the backstage. So currently I'm trying to figure out where the problem could be. The lights and address information we prepared would be very helpful at situation like this to look into specific areas of problem. I found out one of the lights from 10 truss got included in 6 LAN truss. I decided to leave that alone while grouping, which took care of the issue. I re-included the light back to 10 truss toner group and recorded it again to the same slot, which fixed the problem. One of the truss toner static light in 10 truss was having an issue. So I duplicated the adjacent light and replaced it with the one which was having problem. I also made sure to rename and repatch to correct number, and that fixed the issue. A minor issue while prepping information on light set and its address range. The address was entered wrong, which included a light from another set, and it was causing confusion. So that was fixed by fixing the address range. We are on the final grouping, which is pyros. A single pyro has two modes. One is always on and the next is burst. That's why we patched 66 address for 33 pyros so that we could select one mode alone for always on and other for burst by alternatively selecting the dimmer channels and grouping them. So this set of dimmer channels triggers the pyro to be always on. I'll group this. And then select the alternate dimmer channels for burst and group them as well. Finally, it's over. Now let's test all the groups. all working good. Let's proceed to program these lights for music. Here's the music for reference. I'll keep playing the music throughout the programming session. I'll be deciding on style, color and effects of lights group. Once I like it, I'll record it to a fader, which we can later record and bring them to Unreal Engine via Take Recorder. Light programming is different sessions to go through as a whole, so I would like to keep it for upcoming videos sometimes in my channel in the future. Since this is a basic workflow video, we'll keep it this way. Try to observe and grasp as much as you can. Try to play around with settings, you will get the basic hang of it. We'll go through a detailed video on light programming alone later. Let's program. I managed to program few lights for this music. Now we will give a name for all of them to identify what is what. Light programming is done. Let's prepare to record these in Unreal Engine in next section. Let's record the lights from Chamsys to Unreal Engine using Take Recorder. Click on play button in Unreal Engine. Go to Window, Cinematics, Take Recorder. Close the sequencer window which pops up. Click on Source in Take Recorder window. Choose DMX library. Click on Null DMX library. Pick the DMX library from below list. Click on Add All Fixture Patches. Click on the gear symbol at the top, which is the setting symbol. Go all the way down and uncheck Auto Lock. Click the record button. The record starts after countdown. You can now play light sequence in Chamsys and everything will be recorded in the order you played. So I'm just playing all the recorded lights in the order I want, and later I'll sequence them as needed. You will also need to decide how long you need a light to play. The longer you play, you will have more animation keys to manage. So it's all the requirement for music. Once you're done playing all the lights, click on stop button in the take recorder window. Close off the empty level sequencer. Chamsys can be closed now. Go to content browser, cinematics, takes. That's where you'll find the recorded sequence. Give it a name. Import wave format of music into Unreal Engine. Open recorded level sequencer. You will see all the recorded keys. As you scrub through the timeline, you will see the light triggering on scene. Click on track, click audio track, click plus audio, choose your imported audio file. The audio gets imported. It's a 17 seconds music. First, make a copy of entire animation keys set and keep it aside. This will be helpful when you make a mistake. The undo and redo function will not work always, so make sure to move the keys around carefully. Here's a basic navigation of the timeline. I key to set the start playback range, O key to set the end playback range, space to play. Use scroll up and down along with control key to zoom in and out. Simply scroll up and down in your mouse without control key to go up and down. Right click on audio waveform and choose locked. Then right click on audio in the left and choose pinned. The keys which you see on the screen right now holds all the animation keys. As you expand the arrow in the left which has your library name, you will notice there are a lot of keys. So you can select either them in one single shot or by expanding and selecting them individually. Always work with one set of animation keys for a light at a time to avoid overlapping them, which will further confuse you. It also becomes hard to select them. So one light set at a time. I am now starting to match the lights to the music. I might have recorded excess, so I'll set a playback range and then try to fit the recorded lights within that. Finally, fade off the light. I made a mistake in dragging keys to the inside, which could change the animation altogether. So avoid doing this. Undo worked now, but it won't work all the time. I am moving all the Sharpie light keys to the first piece of music. Selecting single line of keys before collapsing the library name on the left has selected all Sharpie keys. I am now making sure whether there are any keys on the top or below. Always do this check. Sometimes because of the way lights are patched, the lights can be scattered all over. Decide a playback range. Place your keys in that range. Isolate the last column of keys for every light, which is the dimmer off. Move it away. Delete off unwanted keys and then move your dimmer off key to a point where you need the lights to turn off. It's same concept as your 2D or 3D animation keying. It's that you're doing it for lights now. You can now select or move columns of light keys either in this expanded fashion or as one shot before collapsing the DMX library on left. I'll be showing you both. Whatever method you're using, make sure to concentrate and be clear on what you're doing. But you will not always be able to move the keys without collapsing them. When you have different sets of keys placed underneath, and you will not know which set of lights you're selecting. So expanded view is always preferred. Closely watch the screen as I match these keys to the music. The blue line is the playback range I was referring to. White line is the current position in this timeline. Whenever you zoom in or out, it will always happen based on this position. You can either copy or cut the keys from a place. I am now filling all the banks with a pyro burst. Keep saving your progress frequently. There are a lot of styles to go about designing lights for music. I am showing you an easy method for this demo. If you notice, this recorded light doesn't have a complete dimmer of keys in one column. Why? Because it's a pattern and it gets turned off and on randomly. So we cannot expect the keys to be in one place, but we need to make sure to have all the keys in place before deleting unwanted ones. You can do that by manually entering dimmer to 0, which is a long process, by moving last dimmer of keys of every light to one place, or by pressing enter to add a key for dimmer 0, which is easier. You will see me doing all these types now. One of the light is left, so we need to figure out which light's dimmer is on and then turn it off. So it's fine for small set of lights, but it becomes tedious when you have lot. So always do this carefully. Unless you mark the playback range, it will be hard to move the keys to desired spot. So set the playback range first. You'll not be able to select a column of keys in one shot if it's longer. Hold shift, keep selecting keys, scroll down and repeat the same until you have got them all. Manually dragging the dimmer off key to end will not work for a longer set of keys. It's a time consuming process and it's hard. So best is to keep a cursor at end point and press enter for all lights either by group or as one by one. Copying and pasting keys also will not work. Now you can see I'm easily placing dimmer of keys by pressing enter. Make sure to do this before deleting any keys. Sometimes when you change the order of recorded keys, you will notice a color change in the light. So it's always best to record in the same order you need lights. It might not be feasible that way all the time, but as much as possible try to maintain the same sequence. I just copied a key and it's not pasting right now. Something happened. So what I'm doing is I'm going to get it back from the backup copy I made in the beginning. Else I would be required to re-record everything. You cannot record a single set of light to a sequencer and then copy and paste it here. It won't work that way. So always back up your keys in the beginning itself and keep it separate as I showed you. The sequencing is complete. I'm deleting the backup keys and adjusting the in and out of the sequence to be rendered. Since we have fireworks in the end, extend the out time further to get it rendered fully. Let's output this in next section. Once you're done, lock the animation key layer as well. If you accidentally move the blue bar, it will change everything at any time. Click on 3 dots next to clapboard icon. Click movie scene capture legacy. Choose either JPEG or PNG sequence. It's just that JPEG takes little space, PNG takes lot of space, and the quality is good as well. Choose the resolution, path to save. The render dialog automatically picks in and out based on your marker. Press stop button in Unreal Engine viewport and click capture movie. Let's wait for the image sequence to get rendered out. Use your favorite video editing program and match the music with rendered sequence. I have the final rendered shot. Let's watch it. And that brings us to the end of the video. Hope you had learned a lot from this video. Hope this will be useful to you in many ways. I would love to see your design and style. Once you have the rendered shot, share me the link in the comment section. If you're stuck somewhere, watch the video again or ping me. Take it slow, as this could be a lot if you are new to DMX. When I learned DMX lighting for the first time, it wasn't easy to learn with resources online. That's why I decided to keep making basics video for you all to understand this workflow easily. So this video was another attempt to explain you the DMX workflow on a big map. Luckily we have Unreal Engine, the team and the lighting designers who has given us a vast map with everything placed already and tested. It's just that we are tuning it to our own. In a similar way, create your own working style from this learning and keep exploring. Good luck with your projects. Once again, a gentle reminder, if you wish to support, we can contribute on the following way, which I'm sharing on the screen now. It's totally up to you. I'll keep coming up with different light shows for this Previs Map sometime soon. Show me yours too when you're ready. Looking forward to see it. Do subscribe to the channel. Stay tuned for more updates. Share this to your friends and family who would be interested to learn basics of DMX lighting. I am Rajashekar signing out. See you on next video.